that the electrons are coming out, and then over here, the electrons are going in. Are we okay with that so far? So what that means is that when you guys took a look at this, and if I was to make this look a little bit more like your YouTube, which was like over here, so remember that you had your solution, and again, it's the same solution. So that means that this makes this the cathode, because your carbon electrode is full of electrons, yes? And then it makes this one over here the anode, because the electrons are all being removed. Now, you guys are dealing with a sodium sulfate solution with carbon electrodes. So at this point in time, the species that are going to be reacting are going to be Na plus, SO4 2 minus, and also H2O. Does this look kind of familiar? Okay, we had done a reaction that's similar to this. Now, when we take a look over here, you saw that I think on the cathode side, I believe that the cathode side turned kind of a blue color, did it not? Okay, so over here, this turned a blue color, and then on the other side, it was a yellow color. So it turned a more intense yellow. And then what you noticed is that on the cathode side, you had bubbles forming, but how did it compare to the side that was yellow? Which side had more bubbles? Which side had more bubbles? Was it the side that turned blue, or was it the side that turned yellow? The blue side was more bubbles? Okay, so I'm going to put in 6 bubbles. This one, I'm only going to put in 3. So now what we want to do is we want to say, well, what are the possible electrodes for at the anode side and the cathode side? So in this case, the carbon electrodes over here, were they going to be involved in any kind of like reaction? Will the carbon actually react? No. So therefore, you're going to be putting a line here and a line here. Now at this point in time, you have the solvent. So what is the identity of my solvent in this particular setup? What's a solvent that dissolves everything? It's the what? I can't hear you. It's SO4? The SO4 is the solvent? What substance dissolves everything? Water. So remember, we said, you guys know that it's going to be water because, let's see, because at this point, if you look over here, do you see this 1 molar, right? You have a solution here, yes? So in this case, what reaction could it happen at the anode side? So what process happens at the anode side? In your redox reaction? Oxidation. So you're looking at the oxidation reaction, and then on this side, you're looking at the reduction reaction, yes? So if you now go back to your data booklet over here, have we not been doing a ton of work with water here? So in this case, when we take a look now, and let me just clean all of this stuff up, we now have 2 potential waters. So over here, you have this water going forward, and that would be your reduction. And then up here, you have your water, and that's your oxidation. So in this case, you're going to come back in here, and you're going to now write the water as it is oxidized. So if I take a look at my data booklet over here, has oxidized, so this is now H2O in equilibrium with 1/2 O2 plus 2H plus 2 electrons. And my E naught over here is negative 0.82 volts. So now if I take a look, what would be the cathode or reduction of water? What is that equation? Can somebody look it up and tell me? What do I need to write down? I'm looking at this one for water. The cathode reaction. Right. So it's 2H2O plus 2 electrons giving me H2 plus 2OH minus, and my E naught over here is negative 0.41 volts. Okay, so now if I take a look at the solute, so what is the identity of my solute? What's the identity of my solute here? Na2SO4. So in this case over here, if we take a look, is Na going to get oxidized or reduced? And is SO4 going to get oxidized or reduced? So what's going to happen with the Na? Reduced, right? So if you look at your data booklet, if you even bother looking at it, it's down here. You have your Na, and it would be in the forward direction. So over here, if you're looking at writing this down on the cathode side, it would be your 2Na plus 2 electrons, giving you Na, and the E naught over here is negative 2.71 volts. And what would be the equation I would use for the SO4? Keep asking lots. Sorry? So where are you looking? What is the number you're looking at? Sorry. Here, so where am I? At the very top? There you go. See, we've already done something with this, yes? So in this case over here, this is going to be your S2. So do I write it in the forward direction or do I rewrite it in the reverse direction? In the reverse, thank you very much. So over here, if you now take a look, this one is your 2SO4, 2 minus, in equilibrium with S2O8, 2 minus, plus 2 electrons, and my E naught is negative 2.01 volts. So now if I take a look, which two reactions should be taking place here? So if I take a look at these two on the left, which are both anode, we choose one of the two. Which one should I choose? A or B? I should choose. Why should I choose A? Why should I choose A? Huh?
Smaller?
What's smaller?
The E
The
value.
absolute value. So there you have it. This is your absolute value that is smaller.
Yeah.
So on this side, which one should I choose? Should it be A or B?
A.
It should be
A.
A. And again, this value is smaller. So if we were to take a look and combine those two, again, we'd end up with 3 H2Os, giving me 1/2 O2 plus H2 plus 2H plus 2OH minus. Now at this point in time, you guys know that this part over here turns into 2H2O, so it cancels out with this one, yes? So your overall is now going to be 1/2 O2 and H2. Now, if you were to take a look at the O2, which is here, that is on the anode side, yes? And it's got the coefficient of 1/2. And then, for the other one, you have H2, which is on the cathode side. Do you see the 1/2 to 1? So does it support your observation that on the cathode side, you saw way more bubbles, didn't you? So you had twice the amount of H2 formed compared to that of the O2. Now, we got rid of the H2O here. So remember that there was the H plus here, and you had the OH minus over here, and we got rid of that. But that is in the overall equation, isn't it? But if you take a look at on this side, do you see how on this side you have the H plus forming? When you have the H plus forming, it's making the solution, that solution, what? It's making it acidic, and then based on your work with acid and base, bromthiamyl blue in an acidic environment does what? Bromthiamyl blue in the acidic side, what color does it turn? It turns yellow. So did you guys see that the acidic side or the anode side turned a little bit more yellow? So that was the presence of the H plus. So in this case over here, this is reinforcing that even though these two overall are going to cancel each other out. Now on the right hand side, do you guys see that OH is produced? So therefore, again, going back into your data booklet, when you have bromthiamyl blue, on the basic side, what color does it turn? Blue. So at this point in time, when you took a look here at your YouTube here, did you see it turn blue? Yes. So again, you guys are connecting all of this together. Okay, you guys are connecting your observations, right? This is not just some sort of theoretical thing you guys do. So at this point in time, I've shown you guys what to do, and then at the E naught cell over here, you're now going to get negative 1.23. Now in this case over here, when we did this sample question over here, and we looked a little bit at the questions over here, let me just come back up in your notes. Okay, so when we did this over here, remember I did these 4 equations and they all had different values. Do you guys see that? Notice in terms of the voltage, the one that demands the biggest amount of voltage is minus 4.07. So theoretically, if you guys had actually put in high enough voltage, you could also be getting the oxidation and reduction of Na plus and Cl minus, theoretically. But because water was there and it required the least amount, that one is going to take place first. So that power supply has enough voltage in it to actually be able to make Cl2 and also Na. Okay? So your job is that you guys are going to finish up table B, 1B, and then you guys are also going to finish up table 1C and 1D. Okay? When you guys see you next, I will talk a little bit about copper plating, so we're gonna talk a little bit about how that reaction works, okay? So right now you have about 10 minutes. My expectation is that you guys are actually working on this lab, not on your cell phones, not sitting and waiting for 310 to come about, okay? And Lee, you can just turn your cell phone upside down so you don't have the screen on top so you're not distracted.